Okay, so now I have a vector v that I have labeled on my picture, and I do not have the component form. Remember, the component form would be if I had this terminal point here, right? Component form would be v1 comma v2. So instead, I have its magnitude, right? Its length, its magnitude is 14. So this is its magnitude is 14. And I have what's called its direction angle. All right. Remember, direction angles, or just angles in general, they start on the positive part of the x-axis, and positive angles will go counterclockwise. So the direction this one's going for 55 degrees. So this question is saying, let's take this vector v and let's write its component form. So I'm looking for basically this answer right here. Well, we can do that, right? We know a lot about trig. And if I'm looking for v1 and v2, that's this point here. So I'm looking for the value here and the value here. All right, so to find v1, which would be this bottom one, right, the x coordinate, I can label it any of those ways. To find the x coordinate, I can use cosine, because that would be the angle adjacent to 55. So cosine of 55 degrees equals adjacent, so that would be v1 over the hypotenuse, which we know is 14. So if you were to solve this, multiply 14 on both sides, use your calculator, don't forget to be in degree mode, you would find that it's 8.03. So there's v1, 8.03. And to find the y-coordinate, which is really v2, then we would use sine of 55 degrees equals, let's see, opposite, so v2 over hypotenuse. So again, multiply by the denominator. Make sure your calculator is in degree mode, and v2 would come out to 11.47. Okay, so that's how we can come up with component form. Now, if you notice, to find v1, what we did was, to find v1 was right here. We took the 14, which was the magnitude of the vector, and we multiplied by the cosine of the direction angle. And to find v2, we did this, which was the magnitude times sine of the angle. You can use that formula if you need to find the component form, if maybe you have the component form and you need to find the angle, but you don't have to. Just using your basic trig knowledge will work just fine. All right, lastly, I have the component form of my vector this time, but I need to find the magnitude and the direction angle. So I have this vector at -1, 2. Okay, so there's my vector, and I need to find the magnitude and the direction angle. Well, I can find the magnitude, let's call it maybe vector v. My magnitude, well, that's just v1 squared plus v2 squared, and take the square root of it. So that would just be -1 squared plus 2 squared. So the magnitude comes out to the square root of, let's see, 1 squared is 1, plus 2 squared is 4, so the square root of 5. So there's my magnitude. And now I need to find the direction angle. Now be careful. The direction angle, we're talking about this direction angle, but we're not going to be able to do that unless we use this right triangle. Okay, so remember, that's like our reference angle, but our direction angle is really this red angle right here. Okay, we're going to use our little reference angle inside, right there. We're going to use that to help us find our direction angle. Okay, so in my picture, I know that the magnitude, which is the hypotenuse, is square root of 5. And I don't know, I do know that the V1 is -1, and I do know that V2 is 2. So I can use trig again to come up with my answer. You could use that formula that we used on the other page, but instead I could just say, well, if to find that angle, I could use maybe tangent of the angle, and I know tangent is opposite over adjacent, so 2 over -1, so I never even have to use the square root of 5 just in case I got it wrong. So if I do inverse tangent, again, don't forget to make sure you're in degree mode, then the angle, so inverse tangent of basically -2 comes out to -63.4 degrees. But if we look at our direction angle, we know that angle is not a negative angle. So what we can do, and we even know that that is going to be bigger than 90 but less than 180. So what we actually know is this angle inside of here is 63.4. So we want to do 180 minus 63.4 because that's how far it is away from 180. So we actually know now that it's 116.6 degrees when you subtract that. So now we have the magnitude and direction angle. This is not the only way to find the answers. You could have used that formula from the previous slide.